Okay, in this video we're going to look at trapezium rule as a form of integration. So this is used to estimate an integral that cannot be integrated by an algebraic method, or maybe can't be easily integrated by an algebraic method. And we're going to look at several integrals that, we do know how to integrate, but we're going to use this process to estimate those. It is an estimate. Trapezium rule is an estimate, and it's based on a trapezoid. So let's look at where we're getting this from. So a trapezoid, that's not straight. Let's see if I can do this better. It's very hard to draw up here. So a trapezoid is a shape that has at least two parallel sides. Okay, so this, for example, is a trapezoid. And we're going to look at this turned upside down, or turned on its side in a second. But basically, the formula for the area of a trapezoid is 1/2 the height times base 1 plus base 2. And so this would be the height in this case. And then I have base 1 and base 2. Now what we want to look at is, how does this relate to a curve? Okay, so maybe I have a curve that looks something like this, and I want to estimate the area underneath using trapezoids. Well, I can actually draw a trapezoid if we think, let's say we want to start at 0. I can draw a trapezoid that might look like this. Okay, and then I can draw another one that might look like this. And from there, I'm going to draw another one, and so on. Obviously, the more trapezoids we use, the better estimate we get, but I can get an idea of this area using trapezoids. Now, for us in this formula, this side is going to be the height. Okay, so you can see here, if this was turned on its side, this is going to be the height, and the height for us is going to be the same for each one of these trapezoids, because we're going to use this formula. So the height is going to be equal to b minus a, and those are my bounds, so my highest bound minus my lowest bound, over n, where n equals the number of intervals that I want to use. Okay, so the number of intervals, or basically the number of trapezoids. Okay, so that's what n is going to be. And this formula is going to give me my height, which in this case kind of looks like width, right, of each trapezoid that we're going to use. Now, what you see here in this formula is 1/2 the height, which we have here, and then this is base 1 and base 2. So if we did each one of these trapezoids separately, if I did this was trapezoid 1, and I did 1/2 this height times base 1, which is this length, which is going to be this y value, plus base 2, which would be this length, which would come from this y value. And then I would do the same thing for this. The height's going to stay the same, but notice that this y value is going to get used twice, because it's going to get used in this first trapezoid and it's going to get used in the second. And then this y value is going to get used twice, because it's going to get used in 2 and 3. And this y value is going to get used twice, etc. The only y values that aren't going to get used twice are this one and this one, so the one on the end. So if you look at this formula, which you do have to memorize, you're going to have 1/2 the height, which is going to be the same for all of them. And then this is going to be your first y value. This is going to be your last y value. Notice those aren't getting used twice. And then the easiest way to do this, instead of doing each trapezoid individually, is to say we want all of our middle y values to be added together and multiplied by 2, because they're getting used twice. Okay, so I'm going to show you this using a couple examples. So use the trapezium rule. Guess I can't talk today. Use the trapezium rule with 5 intervals. That's n. 5 intervals to estimate this integral, giving your answer correct to 3 decimal places. Well, you can see we want to go from 0 to 1. So basically on a graph, I'm trying to find this area. Okay, so what we want to do is, first we want to find h. H, remember, is going to be equal to my higher bound minus my lower bound divided by the number of intervals. So in this case, h is 1/5. Okay, and that's going to be true for every, imagine me drawing a bunch of little trapezoids within that area. Okay, and then what we need is, we need our y values that correspond to these x values. So I'm going to just make a little table. And what I want to do is, I want to start at my lower bound, because that's the area that we want to find. And then I basically want to use this as my width to find all of my other x values that I'm going to be using. So 1/5, 0 to 1/5, that's one interval, plus another 1/5 is 2/5, plus another 1/5 is 3/5, and then 4/5, and then I get to 5/5, which is 1. So that's where I wanted to stop. Okay, so make sure that you start at the right value and you stop at the right value. Now, we wanted 5 intervals. We can check this. This is 1 interval, 2, 3, 4, 5. Notice you have 5 intervals, but you have 5 intervals, but you have 6 x values that you're going to be plugging in. And then you're just taking this 0 and you're plugging it into this equation to see what we get. And so we're going to get 1, because if I plug a 0 into this x, I get 1/1, which is 1. Okay, and then I can plug 1/5 in, and of course you have a calculator that will do that for you. But you're going to get 25/26. And then when you plug in 2/5, you're going to get 25/29. And plugging in 3/5 gives me 25/34. And plugging in 4/5 gives me 25/41. And then when I plug in 1, I get 1/2. Okay? And so you can find those y values. But then what we're going to say is we're going to say the integral from 0 to 1 of 1/1 plus x squared is, oh, and there should be a dx up here. That's a typo on my part. But the interval is approximately equal to, this is approximation. Now, remember what we're going to do is we're going to always say 1/2, because that's part of the formula for a trapezoid, my height, which is 1/5, and then I'm going to put my first y value, which is 1, plus 2 times all of my middle y values, 25/26, plus 25/29, plus 25/34, and so on. But remember that your last y value does not go in there. Your last y value is on its own. Okay, and then basically, guys, you're just doing this math. So the way I would do it in my calculator is I would add all of these in the middle first, take that value, multiply it by 2, add 1, add 1/2, and then, of course, multiply by 1/5 and 1/2. And when we do that on this example, we get 0.784. And that is an approximate area from 0 to 1 of this curve. Okay? Okay, let's look at the next one. Okay, so again, this one's fairly simple. You guys know how to integrate this and evaluate, but we're going to use a trapezium rule with 5 intervals to estimate it. Okay, so again, we happen to have 5 intervals again, but you're always going to do h is going to be equal to your top bound minus your lower bound divided by the number of intervals that you want. And so this is going to give us 1, so that's a nice number. 2 minus -3 is 5/5 is 1. And then we want to make a little table where we have x and y, and I want to start always at this lower bound. Make sure you start at the lower bound, and then my steps are going to be 1 unit in width or height, however you want to look at that trapezoid each. So -3, and then I'm going to have -2, and -1, and 0, and 1, and I want to stop at 2 because that's my higher bound. Just always check. You wanted 5 intervals. This is 1 interval, 2, 3, 4, and 5. If you have 5 intervals, you will have 6 values here that you're plugging in. Okay, and so then you guys know how to store these values and plug them in. Also in class, I'm going to show you how to use the table function, which will make it a little bit quicker. But I want to plug in -3, and when I plug in -3, I'm going to get 6. -2 gives me 9. Here I get 10, 9, 6, and 1. So now that I have those values, I'm going to say the integral from -3 to 2 of -x squared minus 2x plus 9 is approximately equal to, again, this is an estimate, is approximately equal to 1/2 is always there. Then I have my height here, which is 1. And then I'm going to have my first y value on its own plus 2 times all of my middle y values. 9 plus 10 plus 9 plus 6. And then I got to remember my last y value is on its own there. Okay, and then you're just doing this work in a calculator very carefully. And we get that this is approximately 37.5 units. Okay, not too bad. All right, I want you to take a minute and I want you to pause the video and I want you to try this one. Okay, so this time we want 3 intervals. So h is going to be equal to top bound minus bottom bound over 3. Again, this one comes out nice to give me 1. So when I make my table, I'm going to always start here at -2, and then I'm going to go 1 unit each. So -2 plus 1 basically is going to give me -1, 0, and 1, which is where I wanted to stop. That's 1, 2, 3 intervals, so I'm good. And then I want to find my y value. So I'm going to plug in -2 to this part right here. Okay, and when I plug in -2 there, I get 1. When I plug in -1, I'm going to get 1/2. Plugging in 0 gives me 1, and plugging in 1 gives me 5/2. So hopefully you got these y values. If not, go back and check your work and see what happened, okay? And now I'm going to say the integral from -2 to 1 of x squared over 2 plus x plus 1 is approximately equal to 1/2 times my height, which in this case is 1, times my first y value plus 2 times my middle ones. My middle ones in this case are just 1/2 and 1. And then my 5/2 out here. And doing that in your calculator is going to give you approximately 3.25. Okay, so this is an approximation. This gives you 3.25, but is an approximation of this integral. Okay, let's look at this one together for just a second, and then you're going to try it. So the difference between this one and the other ones we've done is this says use trapezium rule with 5 ordinances. Ordinances means this is the number of x values basically that you want to plug in. So when I have 5 ordinances, I actually have 4 intervals. I will have 1 less interval than I do ordinances. So when you do this, you're going to start from 1 and you're going to go to 3, but you should have 4 intervals, but 5 x values that you're plugging in so that you come out with 5 y values. Okay, go ahead and pause this and try that for a minute. Okay, so on this one, what we're going to do again is we're going to say h is going to be equal to 3 minus 1 divided by the fact that we want 5 intervals, or 5 ordinances, but 4 intervals. And remember, n down here is the number of intervals. So there'll be 1 less interval than ordinances. So this is going to give me 2 over 4, which is 1/2. So each interval is 1/2. So I'm going to have x here and y. We're going to start at 1. And we're going to go 1 plus 1/2. And you can do fractions or decimals. It doesn't matter. This will give me 1.5. Plus another 1/2 is 2. Then I get 2.5. And then I get 3, which is where I needed to stop, okay? And you guys can plug in these y values pretty easily, but this is going to give me 5. Here I get 5.5, 6, 6.5, and 7. Notice 1, 2, 3, 4, 5. 5 ordinances, but 1, 2, 3, 4 intervals, okay? So make sure you know the difference. This number on the bottom here is always the number of intervals. If they ask for you the question in ordinances, you have to make sure you know how many intervals that is. Okay, so now we're going to say the integral from 1 to 3 of x plus 4 is going to be approximately equal to 1/2 times my height, which is also 1/2, times my first y value plus 2 times my middle y values, 5.5 plus 6 plus 6.5. Remember that your last y value is not included in that gets multiplied by the 2. So be really careful. Doing that math is going to give you 12. So the area from 1 to 3 is approximately 12. Okay, that's all for today, and I will see you in class.